Now let's just see the question number 2, which says that find all the zeros of the given polynomial if two of its zeros are already given, that is root 2 and minus of root of 2. So it means, as we can see, the degree of the given polynomial is nothing but 4. Then definitely the number of zeros for this particular polynomial is 4. So hence we have to find out the other two zeros. So first of all, let's just start the solution set with the help of the division algorithm. So let us suppose we are taking the solution, or we are starting the solution as the zeros, as the two zeros of the polynomial, as the two zeros of the polynomial. So let us suppose we are taking the polynomial as p of x, 2x raised to the power 4 minus 3x cube minus 3x square plus 6x minus 2 are root 2 and minus of root 2, then x minus root 2 x plus root 2, which is equal to x square minus 2, is definitely a factor of p of x polynomial. As we can see, root 2 and minus root 2, they are nothing but the zeros of the polynomial. So it means that x minus root 2, x plus root 2, they are nothing but the factors of the given polynomial, because they can divide the polynomial. Hence their multiplication, that is x minus root 2 into x plus root 2, that is x square minus of 2, is definitely a factor of the polynomial p of x. So if x square minus 2 is a factor of the p of x, then definitely it can divide the polynomial p of x. And using the division algorithm, we can able to find out the other two zeros of this particular polynomial. So let's just divide these two polynomials. We have x square minus 2, we have x square minus of 2, we have x square minus of 2, and we have the dividend as nothing but 2x raised to the power 4 minus 3x cube minus 3x square plus 6x minus of 2. Now let's just start the division. First of all, we have to take the very first element of the dividend, the very first element of the divisor. Let's just divide both of these terms and we will get the answer as nothing but 2x square. This will be the new term of, or the very first term of the quotient. Now let's just multiply 2x square with the whole terms of the divisor. So it would be 2 of x raised to the power 4. We will get minus 4x square, minus of 4x square. So we can write minus 4x square below the term which do have the x square variable with it. So we are writing minus of 4x square below the term minus 3x square. Again, let's just subtract all these terms together. So it would be negative, it would be positive. So these terms get cancelled with each other. So we will get the answer or the remainder as nothing but minus 3x raised to the power 3 plus of x square plus of 6x minus of 2. Again, the degree of the remainder is definitely not less than the degree of the divisor. It means we have to repeat the process again. So let's just divide the very first term again of the new dividend with the divisor. So minus 3x cube divided by x square is nothing but minus of 3x. Let's just multiply minus 3x with all these terms again. So it would be minus of 3x cube plus of 6x. It is plus of 6x. So I am writing it over here as plus of 6x. Again, let's just change the sign. So it is positive. Hence the terms get cancelled. It will be negative. Hence the terms get cancelled. We will get x square minus 2. Again, we have to repeat the process because the degree of both of these are again same. So when we will divide both of these, we will get the answer as nothing but plus 1. So again, we will get x square minus 2, negative of it, positive of it, both the terms get cancelled, and at the end what we are getting? We are getting the remainder as nothing but is equal to 0. Hence at the end what we can say? We can say by division algorithm. By division algorithm. By division algorithm, if px gx are any two polynomials, then we can represent it as px is equal to g of x into q of x plus r of x. So by the division algorithm, we can represent this particular polynomial as nothing but g of x. We can represent it as q of x. We can represent it as r of x. So as per the division algorithm, we can write 2x raised to the power 4 minus 3x cube minus 3x square plus 6x minus 2 as nothing but is equal to x square minus 2 into 2x square minus of 3 of x plus of 1 plus of 0. 0 is nothing but the remainder over here, as we are using this division algorithm. We are using this division algorithm. Now we have to find out the zeros of this particular polynomial. So let's just factorize them further. We have x square minus of 2. We have a quadratic polynomial, and we can find the number of zeros, or we can factorize this quadratic polynomial using the splitting the middle term method. So we have to look out for the two numbers whose multiplication is 2 and whose addition is nothing but 3. So we can write it as minus of 2x minus of x plus of 1. So it will be x square minus of 2. Further we will get 2x as common, so it is x minus 1 minus of x minus of 1. Further we will have x square minus of 2 into 2x minus 1 into x minus of 1. Further we can factorize x square minus 2 as x minus root 2 into x plus root 2 into 2x minus of 1 into x minus 1. So at the end what we are getting that 2x raised to the power 4 minus 3x cube minus 3x square plus 6x minus 2 can be represented as x minus root 2, x plus root 2, 2x minus 1 and x minus 1. So at the end, how we can find the number of zeros? We do know that in order to find the number of zeros, we have to substitute the equation as nothing but is equal to 0. So it means if we are substituting all these terms as nothing but is equal to 0, then we will get the terms as x is equal to root 2, x is equal to minus of root 2, x is equal to half and x is equal to 1. We are actually substituting each of these terms is equal to 0, is equal to 0, is equal to 0, is equal to 0. So at the end what we are getting the 4 zeros of this particular polynomial as nothing but root 2, minus root 2, half and 1. So this is all about how we can find the number of zeros for any given particular polynomial using the division algorithm.